This question is asking us to solve the inequality and graph the solution and write it in interval notation. And in this case, we have what's called a compound inequality. So we want to combine both of the restrictions here. So we'll set this up like we would singles, and then we'll see what they share. So we've got 3/4 x minus 5 is greater than or equal to -2, and -3 times x plus 1 is greater than or equal to 6. So here we're going to add 5. That's going to give us 3/4 x is greater than or equal to 3. And we'll divide by 3/4. In which case we can flip. So when we have a situation like this, I like to imagine my whole number over 1, and then we'll invert this. So it's going to be 4/3. Our 3's can get reduced, and that's going to say that x is greater than or equal to 4. And now we'll work on the next one. Usually you want to distribute. In this case, it's easier if we just ignore that and just start by dividing by -3. Now here's the tricky part. You may or may not remember this. Anytime you multiply or divide by a negative number, you need to switch the sign. That gets a little bit tricky. Let's take a quick diversion. One of the reasons why is because let's say that x was greater than 0. If we multiply both sides by -1, then that's going to give us that -x is greater than -0, or -x is greater than 0. This is not true. That cannot be true. Because if we're looking at the number line, and here we've got x, now all of a sudden we take -x, it's no longer true that that is greater than 0. That's less than 0. So that's why we switch the signs. So let's go back to our problem. We're dividing by a -3. So when we rewrite this, we want to make sure that we switch our sign. And we've got 6 divided by -3, so that's going to give us a -2. Now we subtract 1, and that's saying that x is less than or equal to -3. So we'll go to our number line, and we've got a 4 and a -3. So let's do 1, 2, 3, 4, and 1, 2, 3. Let's just go ahead and make it 4. We need x values that are greater than or equal to 4. So that's going to be inclusive, going this way. And x values that are less than or equal to -3. So that's also inclusive, going this way. Now hopefully you see the problem here. It's saying that our solution set includes numbers that are both greater than or equal to 4 and less than or equal to -3. That's not possible. So for this particular set, there's no solution. And sometimes this is also called a contradiction.